objectives of this experiment, which are: first, to determine the color of the soft drink based on the absorption spectrum. Second is to determine the wavelength at maximum absorptivity, and finally is to determine the concentration of soft drink based on the calibration curve.
What is a spectroscopy? Spectroscopy is the relationship between electromagnetic radiation and matter. Spectroscopy techniques is mainly used for UV, infrared, and X-ray. For example, white light is visible and consists all of color component in the rainbow. This is when the light hits the scarlet solution, the electron in the solution will absorb some of the light and the other will transmit through the solution that can be seen through our eyes.
To measure the concentration of diluted solutions, one of the most accurate and convenient ways are by using calorimeter and absorption spectrophotometry. Absorption spectrophotometry is widely used technique in analytical chemistry based on the property of molecule to absorb light at specific wavelength. Based on the technique, the amount of light energy in the solution absorbed from the beam light on a particular wavelength will be measured. The color of the aqueous solutions is result from the absorption of certain wavelength of white light falling on the solutions. The color depends on the structure of the solute, as water is transparent. The wavelength of maximum absorption is designed as lambda max. Next, there are two types of analysis that can be done by using visible absorption measurement. First is qualitative analysis, where the wavelength at maximum absorbance from the absorption spectrum can be determined. And second is quantitative analysis, where the concentration of unknown solution from calibration curve can be identified.
Before we proceed with our procedure, there are some apparatus and chemicals that we need to use. The example of our apparatus are solvent bottles, waste beaker, cuvettes, and also sample solution.
Now it's time for the procedure.
First of all, we need to prepare the standard solution of 5 ml until 25 ml. To prepare the standard solution, we must pour a soft drink into a beaker and stir to remove the carbonation. And then, we must pipette the 5 ml of the soft drink into 50 ml volumetric flask and dilute to the mark with distilled water. Cover and shake to make a homogeneous solution. Store in a small beaker. Then, repeat the step using 10 ml, 15 ml, 20 ml and 25 ml of soft drink. Then, start the experiment by using a blank solution to calibrate the instrument and analyze the sample by using the instrument spectroscopy.
Next, preparation of unknown solution. Firstly, the soft drink must be poured into a beaker and stirred to remove carbonation. Then, without measuring the volume, pour the soft drink solution into 50 ml volumetric flask and dilute it with distilled water until the calibration mark. Cover and shake to form a homogeneous solution. The color of unknown solution must not darker than the standard concentrated solution. Then, analyze the sample by using the spectroscopy instrument. From the analysis, record the maximum absorbance and their wavelength value of each solution into a table to construct the graph. After completed data, the workpiece and apparatus must be cleaned up. Since only the soft drink is used, the waste can be poured down the drain. While for the cuvette, avoid any uses of the test tube brush during washing it to avoid any scratches. Lastly, for the wash it apparatus, place and dry it at the specific places.
For the result, to determine the wavelength maximum is by looking the highest number or the highest peak at the absorbance value, then the wavelength shows at 520 nanometers. Next, To determine the concentration of unknown solution for the soft drink is by plotting calibration curve, which the value is at 35%. Calculation part. The question asks to calculate the sample for concentration number 2. So, the soft drink solution is prepared in the 50 ml of volumetric flask. In solution number 2, it is prepared by 5 ml of soft drink is added with 5 ml of distilled water. The total is 10 ml. It's over by the total volume 50 ml times with 100%, we get 20% in the solution number 2.
Next, moving on to the next part, which is discussion. From the experiment, the wavelength at maximum absorbance from soft drink sample is obtained. The diluted 25 ml soft drink is run in spectroscopy with different wavelength from 360 nanometer to 600 nanometer. Different wavelength will show different absorbance. Wait, did I miss something?
I know. You forgot about the blank solution, right? So what is blank solution? Blank solution is actually a solution which contains little to no analyte at all. So it is used to calibrate the instrument. Then you can continue to investigate the prepared solution. But wait, after done all the experiment, the result recorded will be interpreted by constructing a graph. What graph? The graph that will be formed is a bell-shaped graph. The bell-shaped graph is look like this. The bell-shaped graph with the highest peak. The highest peak is called maximum wavelength. So what is the maximum wavelength?
The function of this graph is to know the maximum wavelength absorbed, which is lambda max by the soft drink. Next, from the graph plotted, the reading of the absorbance increasing from 316 nanometer with 0.34 to absorbance until it reached the peak, which is at 520 nanometer with 1.590 absorbance. After 520 nanometer, the absorbance reading relatively decreasing. Based on the result and graph plotted, the lambda max of the wavelength of maximum absorbance turned out to be 520 nanometer. The wavelength of maximum absorbance is defined as the point of wavelength which the solution is most sensitive to the concentration change. How about the color of the absorbance? Oops.
Ta-da! Okay, so what is the uses of this colorful chart? So the colorful chart is used to determine the origin color of our soft drink. Based on the result, the maximum wavelength of our soft drink is 520 nanometer, right? So when we see at this colorful chart, the 520 nanometer is at the middle of green and blue. Even though we see the soft drink is in the red color, but the incident light of the soft drink is actually blue to green. This means that the incident light absorbed is blue to green, but the transmitted light is red because the color of our soft drink used is red. This means the origin color of the red soft drink is actually blue to green.
Next, the unknown concentration value retrieved is 35% from the absorbance value of 1.158. Calibration curve, or also known as standard curve graph, was used to determine the concentration value according to Beer's law. Moreover, based on the Beer's law shown, it can be seen that absorptivity is directly proportional to concentration.
Yes, this is because the A, which is the absorbance, are equal to the negative log baseline transmitting percentage. What is transmitting percentage? Transmitting percentage are the percentage of light transmitted throughout the solution over the intensity of light into the solutions. Or we can say that the 100% of the transmittance equal to the zero absorptions. So from the Beer's law formula, the A, which is the absorbance, are proportional or equal to the constant or molar absorptivity, which is the measure of how well the component to absorb the light, proportional to the B, which is the path length or usually the cuvette width, and proportional to the Z, which is the sample concentrations. So from the formula, we can state that the concentrations are higher the concentration equal to the higher light intensity absorption. It can be shown by the distilled water, which is have the zero concentration and result in the zero absorptions. That's why the distilled water, are known as the blank solutions, are the calibrative solution for the spectroscopy instruments. So from the formula, it results in the linear graph of the absorbance against the concentration, with the constant value of the slope of standard solutions, the unknown concentration be determined, which is 35% from the standard solutions are equal to absorbance equal to 1.158. Thank you.
In conclusion, the color of the soda observed is red, but the color based on the absorption spectrum is blue-green. The wavelength is 520 nanometers. The unknown concentration based on the high absorptivity of 1.158 is 35%.
That is all from us. Thank you.